Renueva is working on making plates and cutlery, but first it needs to make sure the recycled plastic is safe for food. That's because polystyrene foam could pose some health risks. Scientists have found that foam containers are generally safe to eat off of, but some chemicals can transfer into your food or drink, and they can be harmful over a long period of time. And breathing in foam particulates is dangerous. The International Agency for Research on Cancer says one of the main components of polystyrene is a probable carcinogen, though the EPA hasn't classified it as such. Hector and his team are realistic. They know this kind of plastic isn't going anywhere soon. So their solution to waste relies on a circular economy. Reduce trash by reusing it.
Problemática con muchos plásticos es la falta de unión de eslabones entre fabricantes, distribuidores, usuarios y recicladores.
Most recycling facilities don't handle polystyrene foam, and as a result, many people simply throw the product away. Renueva has outreach programs to let people know the product can be recycled.
Cómo los involucramos a través de pláticas, a través de capacitaciones, a través de educación ambiental y empezamos a ir a escuelas, a dar conferencias.
The company says that it now recycles 5% of the polystyrene foam used in Mexico City, but we were unable to independently verify that fact.
Pues lo que queremos es que la gente esté educada para que todos sepan que el material se recicla y más que eso, que todos tengan esta conciencia de que si lo utilizas, tienes que hacerte cargo de lo que utilizas.
Renueva has recycled 1,200 metric tons of foam since its founding in 2014, a small fraction of the amount produced worldwide every year. That helps explain why everyone isn't copying the Renueva model. Most polystyrene products are cheap, in part because more than 90% of them is just air. That makes them very light, but also means you need a lot to make recycling profitable. They're also often covered in food waste and can break apart really easily, which makes them tough to process. There are a few similar facilities that run on the Renueva model, like this one in China. Or the Canadian company StyroGo, which uses mobile trucks to densify polystyrene foam on site. But many people around the world are pushing to simply end the use of foam rather than figure out how to recycle it. The European Union, China, Costa Rica, and US states like New York and Colorado have all announced or implemented bans on single-use plastics like polystyrene foam. Mexico City banned single-use plastics starting in 2021, but that doesn't include polystyrene foam. So the product is everywhere, and it fuels the Central de Abasto, one of Mexico City's largest wholesale food markets.
Descargamos un camión o dos camiones al día de este producto de unicel.
Food vendors like Irene depend on that product's low price.
Los vasos, todo es mucho más económico. El biodegradable se disparan los precios.
That's why plastic bans don't always have the intended effects.
Al contrario, hay un impacto ambiental un poco grave porque este impacto lo que hace es que la ley no va enfocada al consumo, va enfocada a la sustitución de la mercancía. Cuando tú sustituyes una mercancía es ya no consumo plástico, pero ahora consumo papel.
This supports Renueva's main idea, that single-use plastic should be recycled. According to Hector, the solution to all the plastic sitting in our landfills is to use the plastic sitting in our landfills. And any environmental action that doesn't make economic sense isn't realistic.
No se habla de desarrollo sustentable en muchas políticas públicas o temas de este estilo porque solo se enfocan al medio ambiente, pero dejan desprotegida a la sociedad y a la economía. Y la realidad es que pues, no podemos nadar contra la corriente de salirnos de un esquema económico.
Penang is one of the most developed and economically important states in Malaysia. A popular tourist destination, it draws thousands of visitors each year to see its rich natural beauty and cultural heritage. On the other side of Penang's success and beauty is another story. Every day in Penang State, about 1,800 tons of waste is generated. In 1 year, this is about 650,000 tons. Of Penang's waste, about 40 to 60% is food and garden waste. Waste that could be composted to help protect our environment and extend the lives of our landfills.
Our food waste and organic waste can be easily processed or composted and returned to agriculture to produce more food. Food and organic waste are broken down by beneficial microbes in nature into useful products, such as liquid soil conditioners, compost, and humus. We are trying to mimic the natural process by separating and processing food waste and organic waste at source so that they do not end up in the landfill as harmful greenhouse gases.
When food waste is mixed with other landfill wastes, they create dangerous landfill gases that hurt our environment. These landfill gases comprise about 50 to 55% methane and 40 to 45% carbon dioxide. Methane is a potent greenhouse gas that is 20 times more harmful to the atmosphere than carbon dioxide.
According to the Penang Organic Waste Policy, Penangites must divert and reduce the amount of such waste going to the landfill to avoid the generations of methane, which is a greenhouse gas, thereby saving costs in terms of collection, transportation, and treatment in the later stage. In addition to extending the lifespan of the landfill, other discards can be easily recycled if they do not come into contact with the wet organic waste portion. In order to achieve this, Penangites are encouraged to separate their organic waste at source of generation so that such organic waste could be transformed into useful byproducts.
So, how do you identify which wastes are organic and compostable? Organic wastes include these. Inorganic wastes include these. Separating your waste is easy to do. The state of Penang is working with international partners to encourage citizens to compost. The urban services departments of Pulau Pinang and Seberang Perai are piloting these composting projects in various high-rise residential buildings. In individual buildings, participating households are encouraged to separate their compostable waste. As an incentive, if they successfully separate based on the quantity and the quality of their waste separation, their housing block will receive a cash reward from the municipal government.
Saya mengasingkan sisa-sisa makanan daripada sisa-sisa yang lain dan memasukkan ke dalam kontena kas untuk dihantar ke mesin pemusnahan sisa makanan di kawasan perumahan saya. Ia adalah senang dibuat dan ia boleh menghasilkan produk lain yang amat berguna.
以前我不知道食物渣可以变成肥料，所以就丢进垃圾桶。现在我会把食物渣再循环成肥料。
A food waste caddy in your kitchen can help you separate your food waste for recycling and composting. Keep it out of direct sunlight and keep the lid closed.
Plastics is one of the most versatile innovations of our time. It is the single-use nature of plastics that has made it an ecological and environmental poison.
This is where Banyan Nation comes in. We at Banyan Nation leverage mobile technology and innovation to drive social change and solve what is perhaps the biggest problem of our times, that is plastic pollution. Hi, I'm Mani Vajpayee. I'm the co-founder and CEO of Banyan Nation.
Hi, I'm Raj Madan Gopal, co-founder and CEO of Banyan Nation.
Raj and I are passionate about solving real-world problems affecting the lives of everyday citizens. Recycling activities in India were relegated to the informal markets. The informal recyclers, that is the kabadiwalas, do a fantastic job of collecting discarded plastics. However, they lack the technical competence and the scientific rigor to convert them and process them into high-quality materials for mainstream applications and uses. Discarded shampoo bottles and lotion bottles have labels, inks, prints, and remnant products. If those contaminants are not eliminated from plastic completely, the recycled plastic will have these material impurities in them. Recycled materials that contain such material impurities can only be converted into low-value applications such as benches, tables, buckets, mugs, and chairs. As a result, FMCG majors, auto companies, even if they wanted to use recycled plastic for their products and packaging, were unable to use it.
Back in 2014, there was absolutely no data on the ground in terms of the amount of plastic waste that was getting generated at a neighborhood level. So we developed this data intelligence platform essentially to map out all the informal sector, kabadiwalas, raddiwalas, the various collectors and aggregators in the supply chain.
We trained them to segregate the materials based on our quality specifications. Once the materials are segregated, we take them through a series of plastic washing steps. It goes through our proprietary washing technology.
Plastics recycling is an extremely water-intensive process. So Banyan has invested in a state-of-the-art water recovery, recycling, and management system that ensures that not only do we use the best quality water, but it also makes sure that we recover close to 100% of the water that we are consuming, thereby minimizing the depletion of groundwater on a day-to-day basis.
Our proprietary washing technology eliminates contaminants such as labels, adhesives, inks, and other product-related contaminants.
And what you get at the end of it is a very fine, high-quality pellet that goes off into mainstream products and packaging. This is the kind of shampoo bottle that we first started with, only that it was highly contaminated in nature. The plastic granules that come out of Banyan's operations are very close to virgin quality.
And as a result, giving the confidence to the FMCG majors that discarded bottles can be used back for mainstream products and packaging again. This is one of the largest demonstrations of circular economies in action. The next time you go to a store and pick up a shampoo bottle, see if it uses safe recycled plastic. Your actions are not just going to save the environment, but also reward the neighborhood kabadiwala for his all-important work. So maybe the next time you drive down the street, you can stop, wave at your kabadiwala, and say hi to him.
Ladies and gentlemen, we seek your cooperation to put your microphone on silent mode throughout the program. Both committees and VIPs are highly welcome to keep your camera on. I would like to remind the audience to fill up the attendance form given in the chat box later. It is to be mentioned that the event will start shortly. Thank you. Bismillahirrahmanirrahim. A very warm welcome to our honorable speakers, Dr. Ong Huai Chuan and technologist chemist Dr. Faizwan bin Abdullah, Dr. Firdaus bin Abdul Wahab, Chair of ACS Malaysia Chapter, Assistant Professor Dr. Nurul Iman binti Aminuddin, Chairperson Sea-Gic 2021, Institute Kimia Malaysia and Royal Society of Chemistry RSC, partners of Sea-Gic 2021, Pemula Chemicals Sendian Berhad, sponsor, VIPs, organizing committees, and all participants of the program. A very good evening and welcome to the webinar session. For your information, we will be having two webinars shared by two knowledgeable and great speakers. I am Rauda Wardina from International Islamic University Malaysia, IIUM, and I am delighted to be your Master of Ceremony for today's webinar. Without further ado, let us continue to our webinar session. For the first session of webinar, it will be delivered by Dr. Ong Huai Chuan. Dr. Ong Huai Chuan is a researcher at the Future Technology Research Center at National Yunlin University of Science and Technology, UNTech. Now, I would like to invite Dr. Ong Huai Chuan to deliver his webinar entitled Waste During COVID-19 Pandemic, a Blooming Threat and its Effective Solution. Please welcome.
Hi, very good afternoon to all of you. So I think now I need to share my slide first before I start my. Can you see my slide now?
Yes.
Okay, a very good afternoon to all of you. So thank you for the kind instructions and also inviting me as a speaker for this event. So today I would like to share the research outcome about the biomass waste or the waste to biofuel during this COVID-19 pandemic. What is the booming trick and also what is the effective solution for this? So without any further ado, I would like to start my sharing. So before I move to the topic today, I want to have a quick discussions about the energy consumption versus the industry revolutions, because this is the core related with the energy demand, especially for this COVID pandemic situations. So as you can see from the figures here, the first industrial revolution happened during around 1784. So during that time, the main energy consumption is using the biomass, just using the raw biomass as the primary energy consumptions. Then another 100 years later, which is the second generation of the industrial revolution has took place, which everything go to the mass productions, electricity powers, and also we have the assembly line. So during that time, you can see here the energy consumption has changing. The blue color here, the people start using the coal because to fulfill the increase of the energy demand for the mass productions. Then another 100 years later, which is around 1970, the third industrial revolution took place. So the thing is moved to the automatic production. We have the electronics and computers start popular during that time. And during that time, the energy consumption has changed again, which the energy demand moved to the oil and also the natural gas. Now the fourth industrial revolution took place. Everything go to the artificial intelligence and also the big data, robotics, and more welcome. And currently, we are facing also the COVID-19 pandemic situation. So what would be the energy consumption? I believe that the energy consumption would be moved towards to renewable energy or green energy. Why I say so? Because as the current energy consumption, the world are primarily using the fossil fuels, which the oil account around 34%, coal is account around 27%, and natural gas is around 24%. This fossil fuel will generate a very huge amount of the greenhouse gas, also and also the harmful emissions. The total burning of the fossil fuels is great around 31.7 billion tons of the CO2 annually, and our naturals only can absorb half of the amount. For another half of the CO2 emission, it will go to the greenhouse gas effect as well as affect our global warming. So we need to have the awareness to generate the renewable energy with the low carbon to reduce the global greenhouse gas emissions. So currently we are facing the COVID-19 pandemic. So there are no doubt the world are entering the new era since the outbreak of the COVID-19. And as the total case is more than 260 million positive case, and also more than over 5 million deaths at this moment. So we need to take the correct actions. So I will not go in detail about the COVID-19 because I believe that everyone know what is COVID-19. So this has resulted a very serious health and also the social economy as well as the environmental problem. Because with this COVID-19, the disposal of the medical waste are increasing. So this is one of the biggest challenges that we need to facing for every nation or any countries. So what is the potential of the waste treatment technology? So currently there are few types of the treatment technologies. The first two is the incineration and also the landfills. These two are very common and also the simplest method that we can handle the various waste. However, harmful toxic gas will be produced for this type of the treatment methods. For the landfills, it is totally non-sustainable because it also has the virus and we require a very large amount of the land. Then we also have the chemical desulfication and also autoclaving, microwave desulfication. These three are very high effective methods, so it can be solve the waste very well and efficient with a very well established technology. However, these three technology also facing some negative impact, which these three technology also will generate very high amount of the harmful emission, especially for the chemical treatment, which will require very high cost of the agents and also the equipment. And we will also have the plasma treatment, which we can reduce the waste significantly. However, the plasma treatment will require very huge capital installation and also the operating cost. At the same time, the NOx emissions are regenerated. And lastly, we have the pyrolysis process, which is one of the thermochemical process. This is very high efficient and sustainable process. At the same time, the pyrolysis process or the thermochemical conversion process able to convert this waste into other type of the value-added products. So, however, the pyrolysis also facing some disadvantages, which normally the pyrolysis require very high cost of the pre-treatments, because the pyrolysis we need to make sure the waste are in the totally drying condition, so it require very high cost of the drying process. At the same time, it require very high amount of the consumption. So with this all the pro and con of the various treatment technology, so what would be the solutions for the abundance of the medical waste that we are facing now? So the topic I want to discuss today is the treatment process that I want to discuss today is the thermochemical conversion process, which the thermochemical process, as I mentioned before, or the pyrolysis process are facing the very high treatment cost or as well as the high energy consumption. So the technology I would like to introduce today is the low temperature pyrolysis process, which we call it the torrefaction process. Then for this technology, we are using a wet torrefaction. That means what? The process can be go through or the mild pyrolysis process can be go through without drying process. So this will reduce the significant high cost and also the high energy consumption for this overall process. So for our group, we still didn't conduct any disposal or the treatment for the medical waste. However, we have various experience to convert the various waste into some value-added product. So today I would like to take the example of the microalgae biomass and also the various agricultural waste as examples to show the how efficiency this treatment process. So as I mentioned before, the biomass waste convert to biochar. This is one of the examples. So we are using the various biomass waste. For example, the microalgae biomass, because biomass is a very variable product for the pharmaceutical application. However, the biomass waste is totally useless. We need a lot of cost in order to do the treatment for the biomass waste. So that's why we using this thermal conversion process or the torrefaction process to convert this biomass into the biochar. So the biochar that produced can be used as the solid fuel or biofertilizer as well as the bioabsorbent. It depends on the characteristics of the biomass as well as the treatment process. So as the background for this study, the biomass waste are from the microalgae. The microalgae generally has a very low carbon content and low energy content as well as a low calorific value, which is not suitable to be used as a fuel directly or it don't have any application. The biomass waste from the microalgae also contain very high moisture content, which require a very high energy input for the drying process before we go into the pyrolysis process. However, the bio oil produced from the pyrolysis process have these advantages, which include the low chemicals and also the thermal stability. The bio oil that produced is very low thermal stability, and also the high oxygen and also the water content. It also has the strong acidity, which limits the application to use as the fuel or biofuel. So that's why we need to go through the thermal conversion process. The thermal conversion process that we using are called torrefaction. So the torrefaction process is actually one type of the mild pyrolysis. Mild pyrolysis, that means is using the relatively low temperature. If we are using the low temperature, that means the energy input are relatively low and the overall 200 to 300 degrees C, and the reaction time is less than 1 hour. So with this process, we can improve the calorific values and also the energy content as well as the carbon content. At the same time, we can reduce some moisture during moisture content during the process. However, we also at the same time we also want to show that the wet torrefaction process, what is the difference between the dry torrefaction and also the wet torrefaction process. As I mentioned earlier, for the pyrolysis process, we need a very high cost of the pre-treatment because the biomass must be drying before the process. With the wet torrefaction, the biomass can be used directly without the drying process. So this process also called the hydrothermal torrefaction process, which we can using the water as a reaction mediums. Then normally the temperature is between 150 and 250 degrees C with the pressure around 5 bar. So this is a very attractive method because we no need to go through the drying process. So for this study, we have total 4 objectives. First, we need to investigate the dry torrefaction process of the microalgae biomass, and also compare with the other type of the biomass waste. Then the second is we want to see what is the advanced effects by using the wet torrefaction process. And third, because when we are using the wet torrefaction, the reducing sugar that we produce as a byproduct, the byproduct is possible to convert into the bioethanol as well. So lastly, we need to see what is the application, other application that can be used for the biochar that we produce. So this is the setup for the dry torrefaction process. So we are using the nitrogen gas. Then at the same time, we are collecting the biomass as well as the bio oil. So this setup, this is the main technologies I want to introduce for today's study, which is the wet torrefaction process. First, when we have the wet biomass, no matter what type of biomass, today I just throw the microalgae biomass, then go through the microwave assisted heating wet torrefactions. We are modified the microwave reactors during the process. Then we control we control the temperature and also the reaction time. So the reaction time is very short compared to the dry torrefaction process. It happened just 10 minutes. So the product that we produce is the solid biochar and also the liquid hydrolysis. For the solid biochar, we further analyze what is the possible analysis, what is the heating values, the TGA, FTL, and SEM, to see what is the suitable application for the biochar. As I mentioned, the biochar can be used as a solid fuel, the bioabsorbent, and also the biofertilizer. So after we further analyze, we can know what is the suitable applications for this. While the liquid hydrolysis, we can further convert into the bioethanol through the fermentation process. So this is our setup. So for this study, we are using two types of the microalgae biomass waste. First is the Cholera ESP31. The ESP31 is the carbohydrate rich microalgae, while another type of the microalgae is Cholera FSP, which is the protein rich microalgae, because the people is extracting the proteins from this microalgae. Then after that, the biomass of the microalgae are the waste. So we obtain this biomass waste as our raw materials for the studies. So this is the first outcome. When we are going through the dry torrefaction process, the microalgae at the same time also do another type of the biomass, which is the D-oil jatropha seeds, were converted into the biochar. So we can find that energy yields was 96% was achieved with the HHR increased from 19% at 250 degrees C for the jatropha oil. At the same time, for the microalgae ESP, the HHP is improved 45% with the energy yields of the 80% by using the dry torrefaction 300 degree at 60 minutes for the 60 minutes. While another type of the microalgae, which is the protein rich microalgae, it seems like the dry torrefaction has very less impact on this type of the microalgae due to the different chemical compositions and structures for that type of the microalgae. So the detail of the study can found in the paper that is published here. After we take the dry torrefaction as a benchmarking, then we further improve with the wet torrefaction process. So we need to know what is the solid yield for the wet torrefaction process. Then we are using waters and also three types of the acids as the medium for the vectorization process. So as you can see here, the overall solid yield can be obtained more than 40%, while the while the acid concentration is increased, the solid yield is decreased for the ESP31, while the ESP for FSP is still remain the same no matter what is the acid we are using as a medium. So the solid yield is more than 60%. Because why? Because most of the protein are still remain in the biomass or the biochar. So that's why the solid yield are still more than 60%. While the HHE improvement, you can see here for the ESP have very significant improvement of the heating values. So we can see here by using vectorization at 160 degrees C for just 10 minutes. For just 10 minutes, we can have the almost similar result that's shown by the dry torrefaction at 300 degrees C for 60 minutes. So that means what? It means the wet torrefaction process is overall can be reduce the reaction time, at the same time reduce the temperature. This means the overall production cost or the energy input that require are reduced significantly by using the wet torrefaction process. So this is the latest analysis of the biochar that produced. As we can see here, for the raw biomass, we have 3.5% of the H contents. After the treatment, the total H content are reduced for both types of the microalgae biomass. And at the same time, the oxygen, the oxygen content also reduced. So from the wet torrefaction process, you can show that the wet torrefaction process at 160 degrees C with using the acid sulfuric 0.05 mole successfully produce the biochar with the similar HHV, which the higher heating value improvement compared to dry torrefaction for ESP species, while the ash content are reduced significantly, which I show in the result previously in the previous slide. Then, as I mentioned, during the wet torrefaction process, the reducing sugars that we produce. So for these reducing sugars for the ESP31 is the carbohydrate rich product, which have the advantage in producing the bioethanol, which is suitable for the further biofuel or bioethanol productions. So we can see here the overall ESP31 have decreasing biochar yield when the acid concentration is increased. Because why? Because while the acid concentration is increased, the degradation similar change for another type of the microalgae biomass. So while the opposite result, the total reducing sugar increased with the acid concentration is increased. As I mentioned before, the ESP is the which the total reducing sugar are significant highest compared to the microalgae species. So
sorry, but I would humbly want to remind you have 10 minutes more for the
okay, yep, sure. So the total heating values are increased while the acid concentration are increased, which show the better fuel property. That means the biochar can be potentials are to be used as the solid alternative solid fuel. So at the same time, the reducing sugar that we produce can be further converted into the bioethanol. Yep, there are one interesting fact that we found during this study. The 5-HTM we produce as a byproduct, which we reduce significantly. The total reducing sugars will be reduced significantly because the 5-HTM will break the yeast during the fermentation process. Okay, this one, the result I will skip. Okay, I just discussed the main outcome for our research is so that the microalgae ESP with the high carbohydrate candidate is the potential for bioethanol productions. Even though the 5-HTM are the toxic inhabitants for the fermentation process, however, the 5-HTM has others useful applications. For example, we can use as a fuel additive for the polymer of the resin prosecutions. So another part of our study is the biochar that we produce. We found that it's suitable to be used as the bioabsorbent. So our absorbent study, we are using the biochar that we produce for two types of the dye. First is the methylene blue, another one is the Congo red. Then after that, we study the Retius absorbent study. We found that our biochar has reaction with these two types of the dye. So when the absorbent doses are increased at around 1 gram per liter, the total removal percent can be reached up to 85% for the methylene blue, while for the Congo red, when the 2 gram per liter, it can reach more than 95% of the absorbent rate. So the optimum absorbent capacity is 40 milligram per gram for the methylene blue and also the 23 milligram per gram for the Congo red. However, the total effect of the contact time is around 120 hours for the methylene blue and also 4 hours for the Congo red. That's our absorbent study. I mean, from this study, we can find out that the microalgae biochar after the vectorization treatment it can become one type of the microporous absorbent, which the pore diameter is around 0.65 nanometers. Then the optimum absorbent for the methylene blue on coconut grade are at the natural pH, which the optimum absorbent is 1 and 2 gram per liter for the methylene blue and Congo grade respectively. Then the maximum absorbent capacity for the methylene blue is 113 milligram per gram and Congo grade is 164 milligram per gram. So this is another of our study. We also convert this biomass or that available in the tropical countries into the jet fuel, because before the COVID, the air traffic is growing, and also the air traffic also contribute a very huge amount of the emissions. So that's why we have this idea to convert the biomass into the jet fuel. So this is our expected outcome. The jet fuel that we produce in the short cover change, which is around C8 to C16 with the density relatively low compared to the normal biofuel, with the kinetic viscosity less than 8 milligrams mm square per second. So the freezing point must be around -40 degrees. So with the world moving towards on the renewable energy, that we want to reduce the CO2 intensities by 40%, in year 2050. So the biomass waste from the tropical resources are one of the potential biomass and bioenergy sources. So it's important for us to develop a sustainable green technology solution that can be convert the biomass waste into the renewable energy or some other type of the value added product, especially the world are facing the COVID pandemic challenge now. So we need to think what is the better solution for us to treat the waste. So I think that's all for my sharing. So thank you for your attention.
Right. Thank you, Dr. Ong Wai Chuan, for the splendid sharing. Now, it is time for the Q&A session, about 10 minutes. Anyone who wishes to ask any question about this topic can state their question in the chat box. I shall read the questions accordingly to our speaker. All right, so we have one question from Nurul Iman Aminuddin. Hi, Dr. Ong. Is your technology introduced suitable for other type of waste, like food waste?
Yep, as I mentioned, our technology is suitable for the various waste. For example, the food waste, the agricultural waste, or any other type of waste. Even though the medical waste also suitable, but we need to know what is the condition. For example, what is the temperature, degradation temperature, or what is the duration. At the same time, after the treatment, the waste, the biomass waste, or we call it the biochar, can be used as any other application. So this is one of the value added products.
So we have one more from Dr. Denny Susanti. Hi, Dr. Ong. In dry hortification, there is using of Jatropha de-oiled biomass. What is the function of Jatropha de-oiled in this process?
Yep. The Jatropha, because in Malaysia, we have some of the Jatropha tree or Jatropha oil. The Jatropha can be converted into the biofuel or biodiesel. So after the Jatropha is converted into biodiesel, the Jatropha waste, we need to do some treatment. Cannot be thrown away like this. So we use the Jatropha the oil biomass, convert into the some value added product. For example, after we convert the Jatropha the oil biomass into the biochar can be used as a fertilizer.
So one more question is from ACS Malaysia chapter. How does the pandemic affect the abundance of microalgae waste?
Yep. I didn't do any study what is the correlation between the COVID with the microalgae waste. However, as I mentioned in my slide, during this pandemic, the medical waste will increase significantly. So with the current technology, we can use this technology in order to convert or the treatment for the medical waste. In order to convert it into the other type of the useful byproduct or value-added product, because with this we can kill two birds with one stone. First, we can solve the medical waste problem. Second, the product that we produce is one of the value-added product we can use as a as I mentioned, biofertilizer, bioabsorbent, or even can be used as a solid fuel. So it can reduce the treatment cost, also the overall energy input cost. Yep.
So there's another question from Dr. Denny, meaning the biomass here is the combination between microalgae and jatropha?
No. I use this in two types of study. In one study, I using the jatropha. In another study, I using the microalgae. However, we in our group we also do the combination of the microalgae with other type of the biomass. With this, we have the we call it co-pyrolysis. So with the co-pyrolysis, we have some synergetic effect. So I mean maybe the overall reaction time can be reduced, or the product that we produce have the higher qualities. Yep.
All right. Dr. Denny says thank you, Dr. Ong, for answering the question.
Yep, welcome.
And an interesting project.
Yep. If you have any further question or whatever, you can anyone have further question, you can feel free to drop me an email.
So we'll wait for 1 minute if anyone is currently typing for their questions.
Okay, sure, no worry.
Right. So from question from Dr. Denny, one more thing. Yep. Where do you get the microalgae?
Okay, I get microalgae from my partner. My partner, their group is doing the microalgae research. They culture the microalgae. After the cultivation, maybe they extract the protein or some very useful nutrition from microalgae. So after that, the microalgae, my waste is waste. It is a waste. So our group is doing the treatment of this microalgae waste. So we work together with our partner who are producing the microalgae or cultures the microalgae for certain purpose.
So Dr. Denny says thank you, Dr.
Yep.
So we'll wait for another 2 minutes and see if there's any upcoming questions.
Sure.
Ada suara kita di sini.
All right, so there's no other questions.
Yep. Okay. Sure.
One more question, Dr. Ong. What other products are in progress will be developed from this technology other than the Jet A1 fuel? From Fatima.
Yep. In our group, we are we are doing the conversion of the various waste, as I mentioned, various waste into some value-added products. So the product that we produce first, of course, is the biofuel, biofuel or biodiesel, from very earliest. Our group is doing the conversion of the biofuel from palm oil, because Malaysia are rich in the palm oil, into the palm biodiesel. Then second, we convert the various waste into the biomass or bioethanol as well, bioethanol or the biochar. So the biochar can be used as I mentioned, as I show you also in my study, our biochar can be used as a solid fuel or biofertilizer. At the same time, we can use as the bioabsorbent. It depends of the characteristics of the biochar that we produce. Then our group also recently is convert this biomass waste into the jet A1 fuel. At the same time, we also correcting our bio oil, then biogas can be corrected as well. So this is a complete process.
Right. The last question marks the end of the Q&A session. Thank you, Dr. Ong Hoi Chun, for answering all questions and giving a meaningful webinar.
Okay, thank you. Thank you for inviting me to share these sections.
All right.
Okay, see you.
All right. Now, moving to the second webinar by technologist chemist Dr. Faizwan bin Abdullah. Dr. Faizwan is a senior lecturer at the Department of Chemistry, Faculty of Science, University Technology Malaysia, UTM. Without any delay, I am delighted to invite Dr. Faizwan for his webinar entitled New Emerging Pandemic Waste Disposable Face Mask. Please welcome.
All right. Thank you so much, Ms. Chairperson. I would like to ask some time for me to share my slide first. Okay. All right. Thank you. Okay, wait for a while. Should I share entire screen? Okay. That is what should I do, right?
True.
I think I cannot share the entire screen while other participant is sharing right now. So I need somebody to stop sharing. Oh, nobody sharing right now. Okay. Okay, I share now. Share. Okay. This one. Right. Can everybody see my slide right now?
Yes.
Can? All right. I'm sorry for the delay. Okay. Assalamualaikum and a very good sorry. Oh, where's my slide? Assalamualaikum and a very good afternoon, everyone. Thank you so much to the committee of the Sea-Gic 2021, especially for the ACS student chapter of UIAM, and then for the whole committee and all participants. Thank you so much for having me today. Right, and I am technologist chemist Dr. Faizwan Abdullah, a senior lecturer from the Department of Chemistry, Faculty of Science, University of Technology, Malaysia. And currently, I am the research member of Separation Technology Research Group and other more posts that have been given to me. And the title that have been assigned to me to share today is the new emerging pandemic ways, which is I will share most of my talk today regarding the disposable face mask. Okay, how we should deal with the disposable face mask nowadays. All right. Okay, a little bit about me. Okay, I am Dr. Faizwan Abdullah. Okay, I'm a senior lecturer as well as the director and chief executive officer of the UTM spin-off company, which is Pure Aims Technology Samberhad. And then I am a member of a lot of the international as well as the national professional bodies, such as the Young Scientist Network, Academic Science Malaysia, Persatuan Science Analysis Malaysia, Malaysian Board of Technology, American Chemical Society as well, International Water Association, and a lot more. I love to involve in these societies because I can make a new network. I can share my, a little bit of my research, and I can have sharing from others as well, right? And I love to do innovation. I have 2 innovation product that is now currently commercialized, which is the first one is the molluscure technology, which is the technology to remove the toxic metal from bivalve mollusks such as cockles, mussels, oysters, and so on. This could enhance the quality of the product so that we can export, we can comply with international standards for food as well as local standards. And okay, my expertise is actually in analytical chemistry, mostly in the spectroscopy, analytical electrochemistry, environmental chemistry, heavy metals removal, water quality analysis, water wastewater treatment, and also some air pollution study. Okay, and have several publications, which is I highlight this one here. All right. Sorry. Okay, about the pandemic COVID-19 facts and figures. Why I should talk about the pandemic COVID-19? Because my talk today is related to this. Our current situation right now. We're facing, worldwide. Okay, we are facing the pandemic of COVID-19 virus starting from 2019. All right. So what about today? This is the latest statistic. Okay, we have for about more than 260 million people infected by this dangerous virus, right? What about the death toll? Okay, more than 5 million died due to this virus. Okay, and about 235 million, more than that, recovered from this virus. This is quite serious, very serious. We are facing right now this kind of situation. All right, and then what about us in Malaysia? Okay, the new daily case is more than 5,000 again. Okay, keep on a little bit decrease and increase again about the daily cases. All right, and then okay, and we have also recovered case more than the the latest cases. Okay, but it is still in the not so good situation we are facing right now. We have to fight with the new normal that have been introduced to us since since the pandemic started. Okay, and then what are the new normals that we should practice every day? Okay, especially in the public areas, right? Or when you go out from our home to go anywhere, okay, we should always wash our hands. All right, and we should wear face masks. Okay, and then we should avoid the crowded places, always do disinfections. If you don't have any important things to do, just stay at home, right? And we should get medication. If we have a symptom, we should report, right? Go to the hospital or clinics, right? And don't shake hands with others. Avoid to to contact with others physically, and then we should do physical distancing. So this is we are not imagining this kind of thing before the pandemic happened, right? But now we are now practicing this new normal. And what is the most important thing that I will share today is the number 2. What is number 2? We should wear the face mask. Okay. What happened if we don't wear the face mask, especially in public? What happened? Since 1st of August 2019, it is compulsory to wear face mask in public, or you will be fined for 1,000. Okay. All right. So that is the thing that have been legalized. Okay, being enforced. Okay, the fine about 1,000 if you don't wear the face mask in public space, public areas. Okay. All right. So we have a lot of face mask type. Okay, we can see. Okay, just avoid, just ignore the Mentimeter. We will not do that today. All right. All right. Which type of face mask do you wear? Okay, you wear that's my photo there. Okay, wearing a respirator there during the Kim case that I involved previously, the Kim incident. Okay, I involved there to to investigate for the scientific committee. Or you wear the let me annotate some here. Oh, sorry. or you wear this type of face mask, closed face mask. You can see the slide. Okay, you can see my annotation, right, guys?
Yes, yes.
You can see, right?
Yes, sir.
All right.
Yes, sir.
Good, good. Okay. Or do you wear this type of face mask like this, uncle? Okay. Used from plastic bottles. You cut, okay, half of the plastic bottle and do like this. Or you wear this type of face mask. Okay. I don't think this is suitable as a face mask. Okay. Or you wear this camouflage face mask. Okay. No, right? But most of us, which type of face mask do you wear? This type of face mask. What is this? Anyone? What is this? What type of face mask is this? Disposable one, right? Okay, disposable face mask. You know, a lot of this type of face mask available in the market, right? You can buy it anywhere, even at the kedai runcit as well. Okay, anywhere you can buy it. This type of face mask, but when during the first phase of the pandemic, there are shortage of this type of face mask. People sell it with very high price, right? Okay, about three ringgit. I think during that time, 3 ringgit per one face mask. That's ridiculous, insane. Okay, for one disposable face mask, 3 ringgit, right? But after that, the production is increased, right? So it is cheap. You can have it very cheap. Okay, you can have it for 4 ply, okay, 3 ply with a lot of colors, fashion, and so on. But it is still disposable. Okay. Oh, the annotation is annotation is still there. All right. Okay. Okay. So before the pandemic, okay, what is the face mask waste management? The disposable face mask. Normally, who wear the face mask? The medical personnel. Okay, those who work in clinics or hospital, they wear this type of face mask. Okay, disposable face mask. And how it will manage at the clinics and hospital? It is considered as clinical waste, which is under the Schedule Waste Regulation, Environmental Quality Act 1974. The disposable face mask is a clinical waste, considered as a clinical waste. The used one, okay, not the new one, the used one. Okay, clinical waste under the regulation of 2005. So the used face or surgical mask, we call it surgical mask previously. It is being thrown in the clinical waste bin, the yellow one you can see. And how to manage this type of waste? It will be burned in the incinerator. The proper management of this type of waste, okay, because it may have virus, bacteria, okay, and so on. So it should be burned. And then some toxic gases also will be as a result come out with the burning process of the face mask, and then will be managed properly in this incinerator. All right, at the where it should be a process at the normally in Malaysia we have a company called Quality Alarm who manage all these schedule waste. Okay, the place where schedule waste being managed. Okay, all right. And what happened now? Okay. First, we look a little bit on the part of the face mask. Okay, disposable face mask. Okay, we have nose wire. Okay, we need to have the nose wire to tighten the disposable face mask on our nose. Okay, normally made from metals. We have the ear strap to put it. Okay, to hang it on our ear. Okay, then we have several layers of filters. Okay, of microfibers. Okay, which is made from plastic. Okay, we have inside and outside, several layers. Normally, okay, the latest one we have 4 layers. Okay, all right. During the pandemic, everyone wear this disposable face mask. So, where did the disposable face mask end? After we wear it, we throw it. It will be end here. Okay, at the landfills. Okay, because we throw the face mask as the domestic waste. Okay, so it will be bring here at the landfill, will be burned there. Okay, and the leachate will come up also from the waste. Okay, just imagine how many people in Malaysia, okay, about 30 million, for example. And if one person wear the face mask, okay, every day, one person wear one disposable face mask every day and throw it as a domestic waste, okay, where should it end? At the landfill. Okay, just imagine how much disposable face mask will be at the landfill. Okay, and it will be burned openly. Okay, and leachate will come out from this disposable face mask and so on. Okay, so what is the toxic content inside the face mask? In the metal strap, metal wire that you should you should tighten your disposable face mask on your nose. Okay, we have several metals that have been analyzed inside the stainless steel, okay, which is antimony, cadmium, as well as chromium, and also lead. Okay, are these metals dangerous to the environment? Of course, if it is in high concentration. And also the microfibers. Okay, the plastics, the microfibers are the main component of the disposable face mask. Okay. If you can see from the previous slide I show you, it is for, it is made from this kind of microfibers and with 4 or 3 layers and so on. This is all microfibers, plastics. Okay, this is my own analysis. Okay, this is the image of the FISAM. Okay, electron microscope with how many magnification there? 10,000 magnification. Okay, you can see the microfibers. Okay, the first one is the new one. Okay, without any without wearing it or without any exposed with waters and so on. But after that, we try to do simulation to put the face mask in water, several type of, and in a different kind of pH. Okay, and then there will be damage in the microfibers, in the fiber, the fibers, and then forming or emerging a new, pieces of microfibers. Okay, that can be, if it is thrown, if the face mask is thrown away as a domestic waste, it will be available in the leachate. The microfibers will be available in the leachate, and if it pollutes the environment, the microfibers will be there in the river water as well as the sea water. Right, stop annotate. All right. Oh, sorry. Okay. So what about the microfibers? It takes 450 years for the microplastics to be degraded. Okay, 450 years for the microplastic to be degraded. It's a very long time. Okay, then it will be, disturb our environment, our ecosystem. Okay, it can be there in the planktons, since in the planktons and all the food chains, small fish, big fish, and will end with us as a human. We eat fish, right? Okay, so I wrote some article. For example, this one during last year, November 2020, in the Berita Harian about the disposable face mask. It is not a domestic waste. I stress here the disposable should be managed properly, not as a domestic waste. Right, and then some English articles in the UTM Nexus magazine. Okay, think outside the trash. We should think how to manage it properly, okay, without polluting the environment. And then some research has been done, which is from the problem statement. Okay. Lack of awareness, insufficient information about toxic metals and VOCs that come out from the waste, and insufficient information on the microfibers and nanofiber that we release by the face mask. Okay. And we have several objectives there to identify the toxic metals and VOCs, investigate the concentration, how much, and to measure what is the size of the microfibers leached out from the face mask. Okay. Of course, the significance is to denote the potential pollution and to raise the awareness to the public. Okay, we sample the face mask, okay, and then we do the leaching test simulation, we do the method validation and analyze all the possible toxic contents inside. Okay, this is the leaching model. We do some model tests to leach out all the microfibers and metals, toxic metals from the disposable face mask. We do also some method validation to validate our method. All right, this is normal in analytical chemistry. And for the result discussion, this is what we found in the disposable face mask. We found cadmium, chromium, antimony, right, as well as lead. Okay, this is the VOCs, the volatile organic compounds that come out. We analyze it using pyrolysis gas chromatography mass spectrophotometer, right? What is the compounds that dominantly come out from the from the plastic part of the face mask, which is the main part of the disposable face mask, the microfibers. This is all the VOCs: 4-methylheptane, 2,4-dimethylheptane, heptacosane, henine-cosane, octadecane, pyridine, 3-carboxamide, oxime, and so on. Okay, if we search for this kind of VOCs, it is quite dangerous, and of course it will pollute the environment. Okay, so the VOCs in the face mask, the composition of face masks are consisted of polymers made up from a long chain of organic carbon. And then there's possibility of emission of VOCs, of course, I've shown you the result. And in the production of the face mask inner layer, the most common polymer used are polypropylene and polyethylene. This is the main components. Degradation of these plastics produce aliphatic compound from C5 to C17. Hence, it can be deduced that the production of aliphatic compounds such as 4-methylheptane, octadecane, and so on, produced with the face mask raw material, which is the polyethylene. This is the method validation. We have to prove that the analysis have done the method validation. Okay, the quite good one, R squared 0.999. Okay, this is from the method validation for graphite furnace AAS. Okay, LOD and LOQ. Right, and this is a concentration of toxic metals that have been analyzed, leached out from the disposable face mask. We sampled two type of face mask from two markets. All right, Econsafe and Watson. All right, and then there are the toxic metals that come up from the leaching test. Okay. All right, so before the emergence of COVID-19, the surgical face masks are widely used by those working in the health sector with the medical personnel, right? And then categorized and managed as a scheduled waste. However, due to the pandemic, everyone wear this type of face mask and will be, this face mask will be treated as a domestic waste and end up at the landfill. And from the results show that the face mask brought and disposed in the landfill that can be leached out no matter what is the pH. Okay, I shown you the analysis done in several pH. Okay, no matter what type of pH that we try, all the microfibers will come out, of the metals will be leached out, and this leachate may flow into groundwater, seawater, bringing environment concern at the environment scale. With the amount of production of these things, it all accumulates in the ecosystem, right? Since I've shown you, since in the plankton, right, and small fish, big fish, all the life in the food chains, okay, and now also for us as a human, okay. And by the microwave digestion, there are high amount of heavy metals that use to manufacture this face mask, especially on the nose wire part. And then during the production flow, there may be chemical residue on the face mask, including heavy metal, which present in trace amount that may result in a concern among the societies. Okay, what happened is from this type of heavy metals, okay, if being consumed, okay, in a large concentration, lead, okay, kidney failure, cancer, all right, and also bronchial asthma, allergies, okay, ulcer, and so on. Okay, and these heavy metals may be conveyed from the face mask and enter the respiratory tract by inhalation or skin contact. They may also dissolve in perspiration and saliva droplets. Okay, these heavy metals are recognized to pose health risks right? And thinking about the future, the massive amount of this type of heavy metals could generate due to the pandemic, okay, may quickly lead to the accumulated release of these elements beyond the current guidelines limit. So this is the microfibers. Okay, we do simulation tests in 3 types of pH: acidic, alkali, and also the neutral. In all pH, the microfibers will be leached out. Okay, and then yes, as I said, we can see the microfibers being leached out, the damage in the structure of the microfibers, proving that these small parts of the fibers that made up this disposable face mask will be leached out and pollute the environment. The microplastic and nanoplastic fibers exhibit a cytotoxic and genotoxic effect in terrestrial and aquatic organism. These small particles may be easily taken out by the aquatic organism and may affect the food chain. Hence, disposable face mask waste can potentially have a serious environmental impact by releasing this type of pollutants, which is microfibers or microplastics, simply by exposing them into the liquid solution. So what are the recommendations? For future study can be performed using a better instrument. We use a graphite furnace AS. So we should use more high-end instruments such as ICP-MS to show the heavy metal contents or toxic metal content is dished out from the disposable face mask with a very detailed multi elements and with low the limit of detection. And there are also other aspects that can be researched, such as effect of UV, temperature, and so on, that I haven't studied yet in this study. Okay, so what should we do? Okay, what should we do? We should think outside the trash. Okay, instead of just throw away this disposable face mask, we should think how to manage it properly. Okay, without pollute the environment. And then avoid using disposable face mask. This is the most easy step to do is avoid using it. Okay, so use cloth face mask instead. Okay, we can wash it and use it again and again, and do research and innovation on the face mask waste management and suggest the best way in disposing the face mask waste that could benefit all. Okay, I have proposed also to my town municipal council. My here we are Majlis Bandara Iskandar Putri is the council here. They have a grant offered to a low carbon initiative. So I have proposed a design of the disposable face mask smart dustbin using solar, okay, and as a electrical energy, and always have the interval for the to disinfect, okay, all the face masks inside the smart dustbin, okay, and also we can collect all the face masks to do recycle. Yes, am I
Yeah,
about the
so
time?
you have
Yes.
1 minute left.
Okay, 1 minute. I'm going to conclude this. Okay, so now I want to quote from a great scientist Albert Einstein. The world is a dangerous place to live, not because of the people who are evil, but because of the people who don't do anything about it. Right? So if you have problems, okay, we should do something. Okay, we should think. We should do actions. As a scientist, I believe all of the participants also scientists, future scientists. So use our knowledge properly, okay, and benefit all with that. Okay, thank you so much.
Right. Thank you, Dr. Faizwan, for the insightful sharing. Hopefully, all participants find this sharing beneficial and use the obtained knowledge for a good purpose. Now, it is time for the Q&A session for 10 minutes. Anyone who wishes to ask any question about this topic can state their question in the chat box. I shall read the questions accordingly to our speaker. So the first question is from Muhammad Firdaus. Dr. Faizwan, what about the
Yes.
concentrations of the heavy metals and the organic compounds detected in face masks? Are they high enough to pose hazards to human health?
Again, repeat the question.
What about the concentrations of the heavy metals and the organic compounds detected in the face mask? Are they
Okay.
high enough to pose hazards to human health?
Okay. Do you mean when we wear the disposable face mask? Okay, and you know, the disposable face mask itself is made up from plastic, okay, and also you know, for the nose wire made up from metals. I think the question is concerned about it is okay for us to wear disposable face mask. Okay, actually, as I said, my test is only from leachate. Okay, we do simulation test for leaching process, and then we found that the you know, the microfibers damage, okay, and can be broken into small parts if it been, you know, introduced to the solution. Okay, so to say that it is dangerous or not to wear disposable face mask, okay, and it depends on us, because you know, we know it is made up from plastics, and then it can be, you know, leach out with a solution. Okay, and we haven't tested if it can leach out, you know, only from your breathing. Okay, when covered with the when your nose and mouth covered with this disposable face mask. Okay, but as I said, if we already know from my study that it can be leached out from, you know, solution, okay, the microfibers can be damaged or broken into small parts only in the solution. So I think my suggestion to avoid using it is clear for you to, you know, to less worry about it. Yeah, just use the closed face mask. Okay, and maybe you worry if you know, consume the small parts of the microfibers and so on. Okay, just use a closed face mask instead of the disposable face mask. The first one is you avoid, you know, something dangerous happen to you due to the disposable face mask, because we don't know what is actually you know, the component inside the disposable face mask that we are using. Okay, from the brands we bought from the shop. And number two is we don't want to pollute the environment. If you buy or you use the disposable face mask, where do you throw it?
In the dustbin.
Sincerely, do you recycle it?
No.
No, you just throw away, right? So that is a problem. As I said previously, it's managed by, you know, as a scheduled waste. It's okay, but now everyone use it and just throw away. Okay, like a domestic waste, if they throw away properly. And I have do some, you know, I always do a brisk walk around my, you know, house area. Okay, a lot of disposable face masks pollute the environment. Okay, we can see anyway. I love to do you know, some walking or jogging while taking photo of these disposable face masks that have been thrown away everywhere. I have a lot of colors of this type of face mask in my photo, okay, gallery in my phone. Okay, I can show you, but it's okay, right? But that is my hobby right now. Do a jogging and take the photo of this disposable face mask that thrown away everywhere. You know, pollute the environment. Very ugly, you know, to see this type of face mask everywhere on the ground. Okay, so my suggestion is just use the closed face mask and wash it. Okay.
Thank you, Doctor.
Thank you.
So we have another question from Dr. Nur Iman. Assalamualaikum, Dr. Faizwan. From your study, what is the highest metal element detected from the mass waste and the concentration detected? Is the concentration metal leaching getting higher over the time?
Getting higher over the time.
Yeah,
during the leaching test.
Yeah.
Yes, of course, but they have a limit, because the metal that used in the disposable face mask is just, you know, a small part that on your nose to tighten the disposable face mask, right? And my concern is not the you know, not the heavy metal content inside the wire that you are using every day, but if it's used a lot. Okay, if all pupils use this disposable face mask and just throw away as the domestic waste, okay, at the landfill, the leachate will come out. Okay, and then that is you know, part of toxic metals that come out from this disposable face mask. That's also my that is only my concern. You know, of course, when you do a leaching test, after some time, you will see a constant, leach out metal from this disposable face mask, because it's only a small part of metals that used in this disposable face mask. But the concern is, if 30 million people in Malaysia use this face mask every day, okay, and being end up at the landfill, okay, what happened there actually is, this type of toxic will be leached out to the environment. That is only the concern. All right, thank you.
Right, so another question is from Sea-Gic 2021. So Doctor, are there any governmental NGO agencies that specialize in collecting and disposing face masks?
As far as I know, currently, I heard only from Selangor government. They have voiced out this initiative, but didn't start any of it yet. But volunteers, of course, there are a lot of volunteers to collecting these disposable face masks. And actually, I don't know what is the next step when, after they collect all the disposable face masks. What is the next step? What they did to the use disposable face mask. But I have the for me, after searching and discussing with all the my friends, my colleagues, we should do something about it, especially maybe we produce some recycle method for the disposable face mask. That's why I come up with this idea, okay, to propose a smart dustbin for the disposable face mask, okay. And after collecting the disposable face mask, we will separate all different parts of the face mask, the fibers or the synthetic rubbers that used to to hang it on our ears, and then all the metals and so on. So we do separate things on this waste. Okay, we maybe come up with something recycle or use product and so on. We are still thinking about what's next. All right, we do have the idea how to collect right now. We are proposing the Iskandar Putri Council, Bandaraya Iskandar Putri. Okay, so the next step is we are still discussing about it. Okay, as far as I know, of course there are NGOs and volunteers to do something about the disposable face mask, but no, there are no proper management. What can I say? A proper face mask management system or guidelines that have been come out currently, because the government, they said that previously I read an article saying that for this type of face mask can be thrown as a domestic waste. That's why I wrote an article in the Berita Harian. It cannot be treated as a domestic waste. Okay, it will pollute the environment. Okay, so yes, everyone, I ask everyone in this CGIC participants and all the lecturers today to we think together how to manage it properly, because I think since the pandemic not ending yet, everyone will use this disposable face mask day by day. Okay, so let us think about it. And I see Dr. Firdaus commenting there that use Dr. Muhammad Firdaus Abdul Wahab, okay, my colleague here in UTM, he said that use a certified N95, KN95, KF95 type of face mask. That this is certified one is better, because they have do some tests to the face mask. The certified one, of course, it's quite expensive as the compared to the one available everywhere in the shop, right? The certified one is quite expensive. For example, we have 3M brand and so on. They have do all the tests, to make it safe to human. But for all the disposable face masks, instead of the certified one, right? I don't know. They have they have done some tests or not. That's why I said it's quite dangerous, and we better use the closed face mask. There's an article. No, I heard that United States have banned several brands of disposable face masks that contain CNT, carbon nanotube. Just imagine they use carbon nanotube, cover the face mask. Of course, we some of the carbon nanotube will be inhaled inside our body. That is very toxic. US banned several types of face masks from China due to this situation. They use carbon nanotube to the face, to disposable face mask. Okay, and do we have any other question?
I think the last question from Dr. Muhammad Firdaus marks the end of the Q&A session. So thank you, Dr. Faizwan, for answering all questions.
I think there's Dr. Firdaus. I just mentioned about Dr. Firdaus Abdul Wahab idea, but I didn't answer Dr. Firdaus. This is a committee, I think.
Firdaus.
Question yet. Okay, yeah, using closed face mask is one of the recommendation, but doesn't really protect us from the virus. Is there any specific closed face mask available in the market that really protect us? Okay, there's a lot of face mask type in the market, so I search it, or some of it have a fashion type of face mask, and medication type, a lot of it, but we we have no proof about it, right? So just the main concern why we use face mask is to to avoid the infection of the virus, right? And there are also studies that have been done that showing us that the performance of the closed face mask is similar with the performance of the disposable face mask, right? But avoid using nylon one. I think the nylon is not so good for as a disposable face mask, but closed face mask performance is just similar with the disposable face mask. That's why I propose closed face mask.
Thank you, Dr. Faizwan, for answering the last question.
Thank you.
All right. So before we end our webinar today, let us carve a memento together. All students, speakers, lecturers, and VIPs are invited to take pictures for the virtual photography session. You may open your camera. I shall pass this photography session to the committee in charge.
Assalamualaikum. So I think everyone's ready. So 1, 2, and 3 again. 1, 2, and 3. Right, again. 1, 2, 3. All right, thank you.
Thank you, committee. We would also like to thank all committees, brothers and sisters for your support and cooperation, and we apologize for any shortcomings. I would like to remind the audience to fill up the attendance form and the feedback form given in the chat box. That's all from me. Thank you and see you guys at the closing ceremony at 4:10 p.m. after this short break.
Do we have any recording for the talk today?
Yes, we do. It's on live in YouTube.
YouTube?
Yeah.
Okay, thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Ladies and gentlemen, welcome back to the final event of the Southeast Asia Global Innovation Challenge 2021. We have reached to the closing ceremony, and with great honor and privilege, I would like to invite Dr. Muhammad Firdaus bin Abdul Wahab, the chair of ACS Malaysia chapter, to deliver his speech. Please welcome.
Hello, how about now?
Yes, you're audible.
Okay, all right, sorry about that. So let me say my salam again. Assalamualaikum warahmatullahi wabarakatuh, and a very good afternoon. Thank you to Sasha, the MC, and thank you to all our MCs for today, for your hard work since 8 o'clock this morning. Of course, my sincerest thanks goes to the organizing committee for inviting me to give a closing remarks of Sea-Gic 2021. So I was asking, how are you all feeling now? Relieved? Alhamdulillah. So relief for the organizing committee, maybe nervous for the participants, and everyone is probably all tired. But one thing for sure, we are all eager to know who's the winner, right? For this year's Sea-Gic competition. So I will keep my closing remarks short, hopefully sweet as well. This morning, on behalf of ACS Malaysia chapter, I have thanked and congratulated the organizing committee and our co-organizers, IIUM and IIUM Kuantan ACS student chapter. Let me reiterate our appreciation again to all of you. As expected, the event went extremely well. So this is, of course, due to your dedication and unrivaled professionalism in handling all the logistics of an online event. Not easy, I know, but you all have managed to pull it off. And let me especially commend all our participants for their hard work, as we could all see during the pitching session. Thank you for the valuable time that you have spent preparing for the pitching, to join the pitching competition, in fact, this year, and also to the participants of our digital art sub-competition. I had a chance to listen to some of their presentations, and they were all outstanding. This is, exactly the level that we expect to see from the top undergraduate students in Southeast Asia. Throughout the pitching session, we have heard concepts like pyrolysis, bioleaching, bioelectricity, and recently in the invited talks, torrefaction, and many other concepts that were presented in the quest of managing the waste problems that we have today. So this is a complex issue, like Prof. Faris said this morning. And of course, there is no silver bullet in solving this problem. Scientists from different fields with different expertise have to come together to combine the multiple strategies to manage waste effectively. Handling the pandemic requires everyone to work together. Thus, like handling the pandemic, managing the waste created by the pandemic also requires all of us to work together. As a member of the public, we can also play our role by disposing of this waste responsibly, like what Dr. Faizwan mentioned just now. The ideas presented by our participants today would not have been possible without the mentors. So you have them to thank for their undying support, for the ideas given and the coaching provided to all of you to ensure that you are on top of your performance today. I'm happy to say that to all mentors, your students are all very, very impressive. I'm sure the judges had a hard time to choose the winners. To all mentors, I invite you to keep supporting Sea-Gic in the future by sending your best students to the competition. Of course, we cannot forget the valuable family time that our judges have sacrificed today to be with us since early morning until now, if any of them are still around. To Mr. Zamri Abdul Rahman, Dr. Ghani, my colleagues, Dr. Rika and Dr. Akhilesh, I personally thank all of you from the bottom of my heart. I'm sure the students have learned a lot from all of you through your questions and suggestions. Some questions may seem too hard for them, as what I saw just now, but that's what we want, to bring out the best in our students. We push them to their limit today, really. But most of the times, I think, they manage to answer the questions really well. That's why I don't care whoever wins. You are all already a winner for managing to survive our tough judges unscathed. As for the digital art submissions, well, just now it was the first time I saw all the submissions, and it really, touched my heart. So I think all the art submitted really give us something to think about after this, especially regarding the pandemic. Think about the people that we love. Think about the people that are affected by this unpleasant pandemic all over the world. Before I end, let me thank our speakers, Dr. Ong Huai Chuan and Dr. Faizwan Abdullah, who is also our member, for the scientific talks given just now. I'm sure their talks helped put the theme for this year's Sea-Gic into perspectives and provide the real case studies in pandemic waste management. With Bismillahirrahmanirrahim, I officially close the final event of Southeast Asia Global Innovation Challenge 2021. See you again in Sea-Gic 2022. Thank you.
Alhamdulillah, thank you so much, Dr. Firdaus, for closing the event and for delivering your speech. Ladies and gentlemen, next, I would like to invite Encik Zamri Abdul Rahman, the Chief Operator Office from Project Management and Green Tech Worldwide Holdings Berhad WHP, as the representative of the judges to give some feedback or comments about today's pitching session. Please welcome.
Assalamualaikum warahmatullahi wabarakatuh and good afternoon. Nice to be back again. Yang berbahagia Dr. Firdaus Abdul Wahab, ACS Chairperson, Organizing Committees members, participant of Sea-Gic 2021, ladies and gentlemen, as a representative of the judges of this competition, Dr. Rika, Dr. Ghani and Dr. Akhilesh, we appreciate and thanks for your invitations for us to become the judges. We are thoroughly honored to be selected to be one of these. I personally honored because that is what I like to do, to be involved in the universities and the students in advancing their knowledge. As you all know, waste management is a real problem nowadays, and the title of this competition aptly chosen to address the real problem of the world. And I'm very happy that all of the participants has correctly stated in the problem statement in solving the problem. In judging this competition, we found that the ideas and the solutions are very creative and some are very, very innovative. And simple day-to-day life problem-solving solutions, and to outright highly innovative and highly conceptual solutions. I believe the finalists has thoroughly prepared, and their presentation are very, I would say, professional and up to the international standard, and I must congratulate them for their preparation. And honestly, I myself, I believe also all the judges, we learn a lot from the participation of in this competition. There are a lot of innovative ideas and new things that we should reap from this competition. I'm not going to talk more. We had hard time in selecting, putting points. We look for those who are presenting with novelty and innovativeness, viability and feasibility of the solution, industrial scalability, and lastly the presentation of the participants. And but I do not know the result. I myself look forward for who will be the winner. I can't wait myself. May the best win. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Encik Zamri, for the criticism and the feedback. Ladies and gentlemen, for your information, Sea-Gic 2021 had conducted a sub-competition of digital arts under the theme of COVID-19, What's Going On, to increase the awareness on how COVID-19 can affect lifestyle. Submission was received before and on the 25th of October 2021. For the digital art competition, the prize for the first place winner will be Rm 200 ringgit, and second place will bring home cash prize of 150 ringgit, and third place will bring home 100 ringgit. Therefore, without further ado, let us proceed with the winner announcement, firstly for the digital art competition. Announcing first, the second runner-up, third place goes to Lisa Aryani and Irfi Adetriani Putri from Universitas Mula Warman with their artwork entitled Fear of Poverty Beats the Fear of Contracting COVID-19 Risk. Next up, second place goes to The Masked Hero by Alia Akila binti Mat Saifur Rahman and As'ad Muhammad from University Kuala Lumpur Malaysian Institute of Information Technology, MIIT. Congratulations to the two winners. And now, the champion for the digital art competition goes to, with the artwork title Serabut from University Kuala Lumpur Malaysian Institute of Information Technology, MIIT, Shasha binti Mumin and Sain Nazir bin Wan Abdul Rahman. Congratulations to all winners and commiserations to all participants of the digital art competition. Now, the main highlight of the event today. Let us move on to the winner announcement for the pitching competition. For your information, these are the prizes for the pitching competition. We have 3 consolation prizes where the consolation winners shall bring home 300 ringgit and plaque respectively. The third place shall bring home a cash prize of 1,000 ringgit and a trophy as well as the pay. The second place shall bring home 1,500 ringgit and a trophy. And of course, the champion shall bring home a cash prize of 2,000 ringgit as well as trophy and pay. Now, let us go to the winner announcement of the pitching competition. I shall first announce the consolation prize winners. The first consolation prize winner goes to Group SGC18M with the title of the project Effective Medical Waste Management for a Smart Pyrolysis Plant from University Science Malaysia, SM. The next consolation prize winner goes to Group SGC 10M with the title Visualization of E. coli to turn food waste into a USB charging station from University Kebangsaan Malaysia, KM. Next, the third consolation prize winner goes to the group SGC 19M with the project title Fruity, a biosorbent pellet for industrial wastewater treatment from the Suranadi University of Technology, Thailand. Commiserations to all consolation prize winners. I shall now announce the second runner-up of the pitch competition, Sea-Gic 2021. Ladies and gentlemen, the third place goes to Group SGC 22M with the project title Use of Supercritical Water for the Liquefaction of Plastic to Oil from University Technology Petronas, UTP, Malaysia. Next up, our first runner-up that shall bring home the cash prize of 1,500 ringgit goes to Group SGC 14M with the project title of Bio-Leaching and Bioaugmentation as a Potential Method in the Degradation of E-Waste from Monash University, Malaysia. Now, ladies and gentlemen, it has come down to the announcement. The champion for the pitch competition of Sea-Gic 2021. With all the year and all the time that has been spent, it's now time to know who won first place. Ladies and gentlemen, brothers and sisters, the winner of the pitch competition with the theme of waste booming during the pandemic was solving via sustainable chemistry. The winner for the pitch competition of Sea-Gic 2021 goes to Group SGC 6M with the title Esteroprom from Universitas Aisyah Yogyakarta, Indonesia. And the art digital competition. Congratulations, representative from Universitas Aisyah. Commiserations to all participants of the competition. It is hoped that everyone will inspire others to manage waste properly during this pandemic. Now, other than that, I believe that every person can play an important role to create happiness in this world. Because, ladies and gentlemen, happiness is the reflection on our health, especially this pandemic where most of us are, of course, burning out. Ladies and gentlemen, Sea-Gic has been serving as a platform for the undergraduates to exhibit their impressive projects since 2016. ACS IIMK is truly honored to host the Sea-Gic 2021. For your information, this is the second time this event was held and conducted virtually. So for the next Sea-Gic 2022, all the fun and exciting competition program with a new theme will be organized by the next host. Now, are you curious to know who will be the next host of Sea-Gic 2022? Well, then let's find out the next host for the Southeast Asia Global Innovation Challenge 2022 with watching the video. as a symbolic to the handover of the next Sea-Gic host. Therefore, I would like to invite the representative for the Sea-Gic 2022 host, Dr. Muhammad Fadlizil Fasihi Muhammad Alwi, the advisor of ACS University Malaysia Pahang UMP Student Chapter, to deliver his speech. Please welcome.
Okay, thank you, Ms. Chairperson. Bismillahirrahmanirrahim. Yang berbahagia Dr. Firdaus, Chair of Malaysia SAS Student Chapter, Dr. Nurul Iman, Chairperson of Sea-Gic 2021, judges, panels, all committees members, and also fellow students. Assalamualaikum warahmatullahi ta'ala wabarakatuh, and good day. Okay, first of all, allow me to congratulate the organizers, IIUMK SAS International Student Chapter, for the great event today. And also a big congratulations to the winners and of course all participants today. I am pleased to see many young chemists from Southeast Asia countries. We have from Malaysia, Indonesia, Thailand, Philippines, if I'm not mistaken, all in one place. So the wonderful things about Sea-Gic today is that what can I see is the international perspective that has been shared by all participants. So CGIC is not just a